Welcome back to part 2 of geology structures. We were just talking about how water and oil and gas will rise until they meet impermeable rock in a salt dome. We use these salt domes to go for oil. And when you're flying over, you can see these salt domes. We have gotten most of the really shallow ones, so we're starting to go after deeper and deeper ones. All the easy oil we could get, it's gone. Back in the old days, to get 99 units of energy of oil out of the ground, let me redo that. To get 100 units of energy out of the ground, we had to expend 1 energy. To get 100 units out of the ground right now, we're expending 49 units of energy. Why? Because we're going after deeper and harder to get oil. There are people who go, there's a lot of oil, just drill for it, baby. No, we've taken the easy stuff. It's like when you pick the oranges off the tree. You go after the easy ones first, and then you have to go after the harder ones, and each one gets a little bit harder to get. Here's a typical salt dome. Here's salt that has risen underneath sedimentary rocks, and it has both folded and faulted these rocks. You, in this case, get all kinds of little reservoirs of oil that are being trapped underneath this shale rock. Remember, shale is made of clay, and the clay creates an impermeable layer. There are all kinds of reservoirs here. Now, I think it was in Louisiana or Texas recently, miners were dissolving this rock salt, and the land over this area collapsed down right next to a freeway. This is going to be a big problem. What I was talking about going after deeper and deeper stuff, this is the Malcondo well that leaked all kinds of oil into the Gulf 2 years ago. Not much to say about that. Oil is limited, and we're going after the hard stuff. Here is a fold here in Arizona. Kind of cool. Now, a few more pictures of oil and gas getting trapped. They can get trapped along faults. They can get trapped along unconformities. And they can get trapped in these weird structures. Okay, this is Navajo Mountain again. And these little cracks in the rock, they're called joints. They look like fractures, but they're not really fractures. If they were fractures, some movement would have taken place along them. But they aren't. They're just cracks. As this granite, sorry, in this case it's sandstone. As this sandstone rises, the pressure release causes the rock to expand, and you get all these parallel joints. I have flown over this when I was working for the, who was I working with? The Park Service at Lake Powell, and you could fly over this area. It is just beautiful to look at this stuff. And now in a previous lecture, I think we were talking about a dam that had failed. These can be a problem because if you build your dam wrong and there's sliding along this joint, you can get a big dam collapse. That was not cursing. Don't tell your parents on me. Now you get joints a couple of ways. Here we were talking about uplift in the case of Lake Powell area. And in other areas you get what are called joint sets. These are really complicated things. Now let's talk about faults. We all have them. Okay, not that kind of fault. But faults like this, and you may not be able to see what's going on here. So let's look at a more clear picture. The diagram is always better. When you have pressure from the right and the left, sometimes the land here will move up and over this piece, and this piece will be moved down. This is called the hanging wall because in the old days, when you found a bad guy, you'd tie up a rope to this edge and then you'd hang him off here. Okay, not really, but it's overhanging this piece. This is called the foot wall because it's got a really big foot. Hanging wall, foot wall. And in a reverse fault caused by compression, the hanging wall moves up relative to the foot wall. In a normal fault, where you have the pieces of land being pulled apart, the hanging wall moves downwards relative to the foot wall. And you have a strike-slip fault in which the pieces move sideways relative to each other. And then if you have both up and down and sideways, it's called an oblique slip fault just because geologists like to name everything. Now, what would you see if you were in a fault? At a mine shaft right here, it'd be kind of cool. On this side, you would see sandstone, and over here, you would see shale. But what happens along faults quite commonly is they become areas where hot water dissolving minerals can get in, so people will find metals and more precious minerals right along this area. And these faults often are places for mining. If you go north of North Canyon, right along the 101 and 16th Street, there are faults in there, and along those faults there were quartz veins, and in the quartz veins there were little pieces of gold, and a long time ago people were mining that. Now, a normal fault. Once again, in a normal fault, you get things being pulled apart. The thing that drops down is called the graben. The thing that pops up is called the horst. Geologists love to name things. It's not a big deal, but this is important. If you've ever driven from Phoenix down here, up over the Agua Fria area, and then back down to the Verde Valley is a graben. And then you go back up the big climbing thing toward Flagstaff. When you're coming back from Flag, you drop down into the graben, the Rift Valley, and then you have to do that long climbing thing right along here, and then you go past Sunset Point. Now here are some faults. Let's take a look. It looks like this piece is moved up, this piece is moved down. This is the footwall, this is the hanging wall, so this is a normal fault. What's happened here? This land has been stretched out. It's under tension, being pulled this way and being pulled this way. Now again, geologists get crazy with right lateral and left lateral strike slip faults. It's not a big deal. Here is a fault in Arizona, and in this case, it's hard to tell, but here's a layer and here's a layer. And in this case, the land has been pushed together. This piece of land has been pushed this direction, this piece of land has been pushed this direction, and they've broken right along here, and they're actually overriding each other. This is the thrust fault. How big can thrust faults be? This is Chief Mountain in Glacier National Park. Glacier in quotes because, well, there aren't too many glaciers there anymore. What has happened there? Here you have some super old rock that has been pushed up and over much younger sedimentary rock. And then glaciers have come along in the past. They've eaten away the old Precambrian limestone and shale, and the younger shale, believe it or not, is underneath. This is kind of weird. In the case of Chief Mountain, I think it's been moved something like 7 or 11 miles. It's a big thrust fault. Sometimes you see this kind of thing going on. Rivers flowing, and then they get reoriented due to crossing faults. It's kind of hard to tell which direction the rivers are flowing here. All along the coast of California, you have rivers getting rearranged due to strike-slip faults associated with the San Andreas Fault. Now, it's kind of cool when you look at the San Andreas Fault. How old is it? Can you tell? Yeah. Take a look. Here's some granite that makes up the Sierra Nevada mountains, and here's some other granite that's the same kind of granite as this. How did you end up with two separate pieces? Take a look. This part of California is moving north just a few centimeters a year. This part of California is moving south. What was it like a few million years ago? These guys were unbroken. This was the old California. It was one contiguous range, and it has been broken. This is Baja California, and it has been spaced apart from the rest of Mexico. This is kind of interesting. Here, they've built a dam creating a lake on top of the San Andreas Fault. Probably not the smartest idea, but oh well. Here's transform or strike-slip faulting along the San Andreas Fault. Famous rift valleys. Well, there's the Great Rift Valley of Africa. There's the Rio Grande Valley of New Mexico. If you go to Albuquerque, you drop down coming from Gallup, then you'll drop down into Albuquerque, go across the Rio Grande, and then climb back up in the Sandias. Albuquerque is in a rift valley. And then again, the Verde Valley of Arizona is a rift valley. Once again, the Appalachian Mountains of the eastern U.S. are folded mountains. This is just cool stuff. I love looking at this. And here are some crazy folds in the northwest corner of Africa. These are some satellite images I got. These are layers that have been exposed and eroded. And folks, that's it. Thanks for watching.